Yeah, hi everyone. Good evening. Welcome to the mock OPP discussion session today. So we will discuss the question which is available in the mock uh, of the OPP exam. So I hope you have already tried these questions, and these questions we have already used in the previous OPP exam. Okay, so these question is directly related to the previous OPP terms. So you can get an idea what type of question can come. So still I can say that the question level is difficult in the previous terms. This time we will provide the easy question compared to the previous terms. So let me share my screen. So how many of you have tried, and how many of you have completed all fours? Raj, yes, Neha, yeah, nice. So have you completed all four?
No, sir, not all four.
No,
Okay,
sir.
okay.
Sir, I had a lot of trouble with the graph problem and the dynamic programming question.
Okay. So let me share my screen.
I am also having the same problem.
Okay.
And sir, in the first question, with that swap, I'm able to get a better answer with the swap than which is given.
What answer is given?
So
I'm
like
I'm
32
not
was
released.
given.
Oh, okay.
So like for that first initial case, sample case,
Mhm.
I can do more swaps and then get a better answer.
You are talking about the first sample.
Yes, sir.
So what answer you are getting?
Sir, say for example, we swap more quantities. So like instead of so like from the first list, we exchange three, and then we do similar thing with one and three again, and then we get
Mhm.
a better answer. Like, I'm getting 12 that way.
You are getting 12.
Yes, sir.
Oh, very nice. Okay, so
It is
but
not possible, sir.
I think it is not possible because you can swap only the same index element. Are you
Okay,
are you
okay, okay,
following this
okay.
rule?
No, 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 no. We can
Yeah.
only swap the same indices.
Yeah, same index element you can only swap.
Okay, okay.
Okay. So that is not possible.
Even after that, it is not possible, but because you have six.
Uh
No, it would be possible because like first
yeah.
list would contain one, 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 two, 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 and then the maximum would be three.
Mhm.
Maximum would be two, and then in the second list the maximum would be six.
Okay, there are
Yeah.
four twos and two ones. Okay. Yeah.
Mhm. Then it is possible, but here the condition is given you can swap only the same index element, then you will get the 18 answer, minimum answer.
Okay, sir, got it.
Okay, yeah. So first thing, I want to discuss that so some student have the opp on the ninth, and maybe 50% ratio we are allocated. So and some have on the 16th. Okay, so what area you need to focus actually? So I have already posted some things on the discourse related to this. Still I am discussing here. So first thing, we are not expecting the any big algorithm to remember in OPP exam. Okay, so like the AVL tree or any heap algorithms which we used for the Kruskal or Prim's algorithm. So like this type of big algorithm we are not expecting in the OPP exam, but you should able to solve some logical problems related to the basic algorithm. So like you have already learned the binary search algorithm. Okay, so binary search algorithm is not much uh, difficult to remember, or you can also write the code. Okay, so one question is also given uh, in this mock exam, second question, which is based on the binary search. So so binary search, when we can use binary search approach, when we and how we can write the code for binary search. So not exact binary search, sometimes we need some modification in the binary search approach. Okay, So binary search is a simple approach which is given for the searching element if the our input list is arranged in a increasing order. So we can apply the main binary search. But same things, if we have some input in the specific order and we know that what the order is given, and we can identify that order. Um, so identify means when we are using the binary search approach. Okay, so if we can identify that after finding out the middle elements where we need to visit next, and what part we can ignore. Okay, so some modification you can apply on the same type of concept of binary search, and then you can get the answer. Okay, so some type of question can be there, which is asking the solution in log n complexity. Okay, so log n complexity, if the any question which is asking the complexity log n, so you can directly think about the binary search approach, and some logic modification you need to check according to the problem statement, what the problem statement is given, and how you can identify the searching element, how you can identify the movement in the binary search. That logic you need to identify. Okay, so you can practice on some binary search problems. So we have already given some problem in week 2, and week 8 some problem is also given in the live coding session, and in the main practice assignment and the graded assignment. You can just try to revise all these problems. Some another problems basically that, which are related to the some data structure. Okay, so like linked list operation. Okay, so suppose if any linked list is given and you need to delete a middle element, so we have already given many example in the theory question also. Okay, how to identify the loops in the linked list, how we can remove the first element from the linked list, how we can remove the last element from the linked list, how we can traverse the linked list. Okay, how we can remove the middle element from the linked list. So this type of operation you should know. Here we are not using any specific algorithm. So some logic is required. You know that how the linked list is created and how the each nodes are linked. So if you know this, you can traverse the linked list, you can identify the position, and you according to the position you can remove the element by changing the address. Okay, by changing the reference of the nodes, and you can also insert the new element in any position. So this type of basic operation you should know with this data structure linked list. Okay, so you can practice some question related to this, similar to stack operation, how we are using the stack operation, queue operation, how we can implement stack with simple list and with the linked list. Similarly, similar for the queue. So this type of basic dealing with the data structure you should know. Okay, and if we move into the sorting algorithm, so you should know how the sorting algorithms are works. Actually, quick sort, what is the concept of quick sort, merge sort, what is the concept of merge sort, how we are merging two sorted list. Okay, so how the selection sort works, how the insertion sort works, some concepts of the sorting algorithm you should know. Okay, so that can also be used. Otherwise, if sorting is required, you can directly use the Python sort func method. Okay, but some concept can be asked, like the merge operation, like the partition operation of quick sort. This type of question can be asked in any problem related to the sorting algorithms. Okay, so this is the main, and the main Python, you have already done many problems in the Python and many tough problems in the Python where the logic, any specific algorithm is not required, some simple logic is required, like the mock PPA one. Okay, so in this problem there is no any specific algorithm is required. We are simply swapping the elements and finding out the answer. So here this is the logic required. If we move to the next uh, graph algorithms, yeah, that's are important. Okay, so all graph all means if we talk about the shortest path algorithm, if weights are given, so you have three algorithms. So no need to learn all three algorithms. You can learn any one which you are comfortable. You can learn Diast algorithm, you can learn Bellman Ford algorithm, and you can learn Floyd Warshall algorithm. Okay, so which you are comfortable, you can learn the concept.
Sir, just a doubt, sir. In those shortest path algorithms,
Hmm.
it can be optimized to n-log n in the Dijkstra's case. So will
Hmm.
they,
No,
sir, they
this type
won't
of
ask us to
no.
do it in n-log n or
This type of
something, no?
complexity levels we are not asking.
Okay,
We are not asking the complexity in the graph algorithms. Okay, so we know that you can use heap or any other things to improve the complexity. Okay, so question will be simply based on these algorithms, and you can directly use.
okay, sir.
Okay, so in shortest path, you have three algorithms, so try to remember at least one algorithm. Okay, so if any problem is dependent on the shortest path algorithm, so you can directly apply.
I would
Okay,
advise people to learn the Floyd virtual because it will solve all the problems.
it provides the shortest path between every pair.
Exactly. So it
Yeah.
will solve the problem for every pair, and it will also solve the problem which Bellman Ford is tackling, and
Hmm.
it will also solve Dijkstra.
Yes, yes.
Meaning it
So
will solve the
if
negative weights as well, and it will also give the all the shortest path. So I
yeah,
think that would be the one to pick.
yeah, definitely we have seen this scenario in the previous OPP exam, where we just asked this any shortest path problem. So most of the student write the Bellman Ford.
Bellman
Okay.
for the easiest to remember.
Yes.
Concept.
So you can use any. Okay. So if you are comfortable with the Diest algorithm, you know the all the concept. If you can write the complete Diest algorithm in the minimum time, so you can write Diest algorithm. Otherwise, you can follow the Bellman Ford and float Varsal algorithm. So purpose are same. All algorithm purpose are same. Okay, so you can use any. Similarly for the spanning tree. Okay, spanning tree you have two algorithm: Kruskal algorithm and Prim's algorithm. Yeah, Braj.
Sir, I wanted to ask, what if like you're saying, we can remember any one of the three algorithms. So
Hmm.
what if we are asked about negative cycle graph question?
Hmm.
So then we'll have to do Bellman.
Yes, then you have to use Bellman Ford. Okay,
Okay.
so you can target Bellman Ford algorithm, because Bellman Ford are working the both type of graph with the negative bits and without negative bits.
Oh, okay, sir.
Okay,
Okay.
so but if you are comfortable in the all concept, you can remember all three. So that is the positive side. So there is no problem if you are learning extra. So but if you have less time and you are feeling that you are not prepared for the OPP exam, so at least prepare these basic algorithm. And
So, sir, I feel very comfortable with Dijkstra. So
so you
Dijkstra I
can
have
dash
already
the,
done.
yes, you can apply the extra.
Okay.
Okay, but if any problem that contains the negative weights, then you have to write the code for Bellman Ford.
Okay.
Okay, so that things you keep in your mind.
Sir, what
Okay.
are we discussing now?
Sir, similarly for Kruskals, they won't ask
Yes.
for that optimized version,
Hello.
right? Like using
Yeah,
the
Manan,
union
actually,
find and
Manan, we are talking about the OPP exams. What area you need to focus
Yeah,
for
sir,
the
can you
OPP?
please repeat? I just joined. Please, if you could.
Okay. So actually, I'm talking about that some area like sorting algorithms concept. You should remember how the sorting algorithms are working, and
Mhm.
so if we are talking about the quick sort algorithm, then how we are performing partition part. Okay, so that partition can
Yes.
be used any problem. Similar for the merge sort algorithm, how we are merging two sorted array, uh, and how we are performing merge sort algorithms, what is the concept behind that. So that things you remember. And the similar for the searching algorithms, so binary search
Binary
algorithm.
search. Yeah.
Okay,
Okay.
and one more important thing, still many of you are writing the binary search code with slicing, and after that you're posting on the discourse that the code is not passing. So we have already said these things many times in the before starting the course. So after starting the course, uh, please don't use the slicing in the binary search code. Okay, if any question is related to the binary search algorithm, and where you need to write the binary search approach, so don't use the slicing, because slicing operation con- complexity is order of n, and our required complexity is log n. So if you are using this operation slicing, so you will not get your required complexity.
Instead of slicing, we can use divide the list and
So you can use simple looping concept of the binary search. You can use the
So
using the while loop.
very
Yeah.
effective. While loop was very effective in the question
Yes.
that is given.
Yes. Okay, so you can
So
use the
can we
simple.
go? So can we go binary search with the recursive method?
You can go, but in the
But there is
recursive approach,
slicing.
but do not use the slicing.
Then
So
how?
no, you can use. I have already given the implementation. If you see the in the GitHub notes.
week 3.
Which week, sir?
Week 3. So searching all 3 type of implementation is given. No, week 2.
Week 2, but I guess in the binary search there is slicing only.
Searching where there is binary search. Yeah. So this is the implementation. You can see with the slicing. Okay, and we
Yes,
have
sir.
already mentioned this statement below this implementation. Do not use. Okay. And another implementation you can see without slicing and using the while loop.
But it's not this recursive method. It's a recursive method.
Yeah, so you can see recursive here.
Yes.
Okay, so in the recursive method, we are passing the list, and we are also passing the starting index and last index. Okay.
Okay.
And what is the searching element?
Okay.
So we are not passing the list after slicing. So slicing is provided the new list. Okay. But
Yes,
here
sir.
we are passing the complete object L, and we are passing the what area we need to check again. So we are passing the starting index and last index, this S and mid -1. So using this starting and mid index, we will decide what area we need to search again. Okay, so this implementation is given using the recursive without slicing.
Yes.
Okay, so binary search approach, if any question is given where we are asking the complexity log n, so you can think about the binary search approach, but do not use the slicing to achieve this log n complexity. Okay, so but you should know where we can use the binary search approach and how we can write the binary search code. And if some so binary search is not, this approach is not only can use for the increasing order. Okay, if you know if you know the order which have the elements in a specific order, and if you know the order, how you can find the element, and what is the identification of searching element, and how you can identify that the area which you need to search in the next iteration. So you can also use this binary search approach after some modification in different type of inputs, but some pattern you should know in the input. Okay, so we cannot say that we can apply the binary search on the random elements. Some patterns should be there, and that patterns should be clearly identified. Okay, and the remaining things we have already repeating this thing. So the next part I'm talking about the linked list operation. So linked list, how we can deal with the basic data structure like linked list, stack, queue, and how we can use dictionary, how we can use the Python list. So these basic data structure, how you can deal with this these type of basic data structure. So similar basic operation like how if any class is given. Okay, so if a class is given for the node, then how you can create a linked list. If some elements are given, how you can create a linked list, and how you can traverse the element in the linked list. If linked list is given, how you can traverse all the elements. Okay, and if any element is required to insert in the linked list, how you can add new element in any position, how you can delete the element from any given position. So these are some basic operation. Okay, and all these operations are also given in the GitHub page. You can just revise these things, how these operations are performing: insert element, delete element, and traversing is the main important part of the linked list. If you are performing any operation, you need the traverse first. Okay, how you can traverse the elements, how you can identify the last element. So these basic operation you should remember with the linked list, and basic stack operation, post pop, basic queue operation, NQ, DQ, how we are performing with the simple list, and how if it is implemented with the linked list, then how we are performing these operation. And next things, graph algorithms. I'm talking about the graph algorithms. So we have two beaks for the graph. First is beak 4 and beak 5. So I'm talking about the beak 5 for two topics. For two topics, first is shortest path algorithms. If weights are given, then we have the shortest path algorithms, and similarly for spanning tree. Okay, and we have already given some problem related to this. So how, what type of problems can be created for the spanning tree, and what type of problem can be created for the shortest path algorithm. So in the both type of problems, yeah, so you have a three algorithm in the shortest path and two algorithm in the spanning tree. Okay, so if you are not comfortable to learn all three and all two algorithms for the both topics, so you can at least learn one algorithm from each topic. Okay, you can learn either Dijkstra algorithm or
Dijkstra or
yeah,
Kruskal.
Bellman. No, Dijkstra and Kruskal are both different purpose. So in the
Yeah,
shortest path
yeah.
algorithm, you can learn Dijkstra or Bellman or Flood-Warshall algorithm. Okay, and similar for the spanning tree. If you are feeling Kruskal algorithm is easy, then you can follow the Kruskal algorithm. Okay, if you are comfortable with Prim's algorithm, so you can learn the Prim's algorithm. So these are some basic algorithms. So no need to learn every algorithm. Just just try to cover each topic. Okay, shortest path problem, you can learn one algorithm. And
Sir, in graph searching, sir, will DFS and BFS questions be there? Like,
yes. So I've discussed about the beak 5. Same things for the beak 4. So main problems are the in the beak 4 is traversing algorithms. You have two traversing algorithms. Okay, DFS and BFS. So BFS is also important if shortest path is asking in the graph where the weights are not given, and shortest path is asking related to the minimum number of edge in the path or minimum number of nodes in the path. Okay, so this type of problem you can directly apply the BFS algorithm. So you can just revise the BFS algorithm, DFS, and there is one topological sort, and topological sort is also similar on the similar concept of the BFS DFS. Okay, so from beak 4 you can remember these three basic algorithm. You can learn
Sir,
these three algorithm.
there is this question in this OPP mock. I think the question 3. They are basically asking us to detect a cycle. So there, I think that post prep concepts can come. I think, sir, will those
No,
concepts
no, no,
also?
that question is not related to detect the cycle
Oh,
actually.
okay. Then I am making
Yeah, I think
mistake.
you missed something. Okay,
Sir,
so
those
yeah,
things will also be important, or we can
post
kind of.
pre, it is not much important. But basic algorithm BFS, DFS, topological sort, and one algorithm from shortest path and minimum spanning tree. It is enough.
Okay, sir.
Yeah, Nachiket.
So how much content will be there from like week 7, the trees and everything?
Yeah. So after week 5, actually algorithm approaches are given. Okay, so the divide and conquer approach, greedy algorithms, and DP algorithm. Okay, dynamic programming algorithm. These all are approach. Okay, there. So here we are not asking any specific algorithm which you have learned. Like we are not asking the code for integer multiplication. So any problem can be given that follow these concept, greedy or dynamic programming or divide and conquer. Okay, so you can just think about that, how greedy actually works, how we can perform the greedy operation, how the divide and conquer approach works, what is the concept of divide and conquer, and similar for the dynamic programming.
So
Okay,
this
so here no need to remember any algorithm which is taught in the lectures, but approach you should remember how we can apply the dynamic programming approach, how we can apply the greedy approach. So these are the things. After big 5 you can just remember the concept of each approach. And same thing for the DP problems. Yeah, DP is little bit tricky approach. So, but you can just practice on some basic question which are given in the live coding, and weekly assignments. So you can practice on that. And if you are not remembering DP, you can also use recursive approach, because the DP is just provide the efficient solution. Okay, you can use the any recursive approach. You can also apply the recursive approach if you can find the solution. Okay, so these area you need to focus. So at least uh, till week 5. Okay, just try to complete all the things. Week 4 and 5, all algorithms, basic algorithms.
Sir,
Sir, how
uh,
can I attempt GRPS because the suffix code is not available? I cannot copy paste and do on the other IDs.
Sorry, what's your question?
How to attempt the GRPA again? Because the suffix of GRPS questions I cannot see
Mhm.
them. In the PPA case, I can
So
see.
GRPA we cannot open due to limitation of the portal, because the your grades are directly related to this GRPS. But practice problems and live coding problems are still open. You can practice on that.
so the solution code of GRP, we can refer to that, right?
Yeah, you can. If you have already solved GRPA, so why you need to write the same code again? You should practice the problems
Yeah,
which you have
just
not done.
mm,
Okay, so live coding problem you can see, and the practice programming. I have already seen the your performance data. So many of you have not attempted the live coding problems and practice assignment. Only most of you are attempting only graded programming assignment. So you can practice on that part.
Sorry to
or
say,
is
sir,
the
but
Huffman algorithm important for coding?
No, we are not asking any specific algorithm.
Okay.
Okay, so we are not asking directly specific algorithm like Huffman
Huffman or
coded
any
AVL or
closest.
closest pair. This type of algorithm we are not asking.
Okay.
Okay, so OPP
But
exam more is related to the logical side, not the memory side.
sir, there was one question in Hoffman coding light session where there was one encoding was given and the dictionary was given, and we were asked
Hmm.
to say if this was a valid encoding.
So I think this is very simple, logical based question.
Okay, so this sort of question will be asked.
Yeah, so some if some logical things is required, then it can be asked. Okay, but we are not asking the how the Huffman trees generate. So the that part is uh, complex. Actually, how you can write the code for Huffman tree. Okay, if some logical things is required, that can be asked.
Okay.
excuse me, sir.
Hmm. Yeah, check.
Yes, sorry to say this, but like I believe that you actually listed down all the content actually for the first 5 weeks. And what
Hmm.
happened is actually some of us were expecting the PP on 16th, and last night we received the mail that it has for for us it has
Hmm.
been
I
made
received it
9th.
today in the afternoon.
Exactly, it is like a shocker because I've not practiced at all for that, and I just have 2 days that.
Yes, sir, it is too close.
Yeah,
And
actually, Archie, so what is the problem? Actually, everyone want to give the exam on 16th.
so yeah, but then
You
why?
know,
Then at least don't open the forms, right? Because now it's I have no. I was actually practicing for the other OPP, and now I'm just stuck. Like, what to do now?
Hey, sorry
Sir,
to interrupt.
another
So,
thing,
did
sir,
the dates change recently? Like, I didn't receive any email.
What?
Like,
Sorry.
did the dates change recently or?
no,
The,
no.
the confirmed dates have been mailed to you.
Mail to you.
Yeah,
Slot
Okay,
is given.
that's
but
the final, right?
That is
Yeah, that
final.
is final.
Yeah,
Yeah.
okay.
those are final. But those may not match what you had submitted.
Hmm.
Uh,
Actually, what we have seen in the previous terms, so generally in the first date, only maybe 50 students are giving the exam, and the remaining 95% students are giving on the last date. Okay, so
Most
every
of the students like to
yeah,
give in the last date.
yeah. So the operational team actually have some limited proctors and the other things, so resource. So
Not
yeah,
like 2 days,
But
just
we have another OPP also on that day.
yeah.
So
Sir,
I would
sir,
just
I get the operation team part, but at least we should be informed at least a
correct.
week ago that
Exactly.
you have to
Yes,
give
sir.
it in the 9th only.
Just
See, sir,
Yes, so that would have been
today I am receiving
better.
in the afternoon, and it was a shocker for
So
me
I
that
think
okay, now I have to do everything within 2 days. That's the problem, sir.
I would just request if you could just like advise on to what specific topics could we focus, because now at this point it is, I don't think it is feasible for at least
Sir,
me
I
to.
think they should
Sir,
make the
I
exam on
think,
the 9th easier.
sir,
I
even
mean,
if
like,
it is like attempt any 4 out of 6, something like that, because if there are
Yes,
only
sir.
4 questions and
And we have to attend
I
all
haven't
4.
able to do all the topics in these 2 days, then I think I am
yeah.
definitely
So
going to miss
suppose
1 or 2
yeah,
questions.
suppose if we give 5 questions, so definitely it will consume some extra time. Otherwise, you will confuse with some extra questions. So what you need to skip and what you need to do. So it maybe consume some
Sir,
extra
the same
time.
problem. Same problem I am also facing. I am leaving the exam. I am not appearing. I have given my consent as no, because I am not here. I cannot. I have tested in the laptop. I am out of because we are in the special duty on that. So how can we appear? The next, if the operation team is facing problem, then prefix on the day of admission, then your test will be on this such and this such date.
so
There is no option.
I would just request you, like, if any form of help, if you could provide, I
So
mean, that would be.
this time I cannot say anything because operational team is thinking they want to conduct the exam in the 50% ratio on the each date.
I get that, but at least inform us, like, some time
Yes, sir.
back, right? Just
Some
not
notice should have been given.
not just like
Operation.
2 days before the exam.
Sir, only due to this operations team facilitation, we are facing the problem.
Yes, sir.
So
So
why
Sir,
are they not
I also
fixing?
want to mention
60%.
another thing that many of us haven't studied week 9 that well because
True, very
when
true.
we switched to only up to week 8 was coming. So that is also another
But
issue.
week 9 is, I
so
think, the
week
very
9 is already completed
trickiest.
before the exam. Okay, so deadline is already over before
Like
the
the biggest shocker is like just 2 days before the exam, without preparation, I'm just like stuck. I can't do anything now.
But operational team is saying that they have already mentioned this thing. This is not the final schedule.
That is fine, but like at least inform us like couple of days back, right? Like not just
At least a week before. You
exactly,
should have
At least a week before
Yes,
it
sir.
should be created.
not just like they can't just inform like tomorrow you have an exam. You can't, like,
Sir, options would be nice. Like, say, for example, we have 6 questions and then we can attempt any 4. That would be better.
I mean,
6
any form.
question and you want to attempt 4.
At least one thing can be done. One who do not appear in the exam, they should be given opportunity in the next session. That's why
Then
in this
nobody
hope,
will be appearing in the exam.
I don't think that is a possible
no, this is
solution,
not
but
possible.
This is yeah, correct. This is not possible. Everyone will skip. Most of the 50% or 60% will skip.
True.
but if you
The only thing is
Sir,
that
I have
those
my
who are
DBMS
appearing in
exam
the
on the same.
16th, they all will be doing better than us. That's for sure, sir.
exactly,
Yes, sir.
yeah,
exactly.
They will
No,
have
this
access
is
to more
this is
questions
your
that are
myth,
being
bro.
asked.
I mean,
that's
don't.
sure. That's sure, sir. Because the
Some
time
form,
synchronization is not matching with that.
so if you could just like give some specific advice, I mean, nothing would beat that. And at this point, I don't think anything like I'm.
To whom we should
To
request?
this point,
To whom we
I have
should
already mentioned this thing. So you can just prepare till week 5.
So honestly, you just mentioned all the algorithms.
Sir, week 2 to
Not
week 5
all,
are
not all
most important,
algorithm.
right,
Okay.
sir?
So what was left, sir?
Only
Hello,
I am
sir.
just saying that just
Emphasize
learn the
on week
graph
5.
algorithms.
Sir, I'm saying week 2 to week 5 are the most important, right,
Everything
for
else will be
OPP?
based on the logical part. Okay.
Sir, or is there any question which is only dependent on dynamic programming or
Yeah,
divide and
definitely it
conquer?
may be.
Yeah, definitely one question will be there.
Yeah, one question will be based on either on greedy or dynamic.
So please have options then, sir. The options would be better.
Our request, you can forward, sir,
Sir, it will
whatever.
be
So
very,
this is
very much
actually
help.
No.
Any form of help would actually, like, it will help.
But
Like,
I think now it's too late. Already we are 48 hours left for exam.
Yeah, so I think you should focus
Already,
on the
More than
al- I,
48
I,
hours.
I,
yeah.
already I have sent a mail in advance, sir. I am not going to appear because how to?
Hey, please try to give exam, okay?
There is no
No,
pass
sir.
criteria. That is the biggest advantage. This time.
I can't, sir. I can't.
I
I
think
can't
Yes, sir. After
because
watching the mock, sir, I
thought
said I was not able to solve three questions. I said
No.
it
So
might be
mock
like that.
difficulty level is actually this mock is given from the previous term, from the starting terms. Okay, so maybe first or second. So that time actually the question difficulty level was high.
Okay.
Okay, so you can expect the compared to the EG level
Mock
in
level
the
is
OPP exam.
will be similar to OPP. I mean, somewhat.
Mock level is high
This
compared to the
time.
OPP. Yes.
Okay.
Okay, so you can expect the EG level compared to
Okay.
that.
so. My final request would be if you could give some filtered advice. Rest,
So we have only 4 questions in OPP exam. How much we can filter?
so I mean,
Sir,
I
options
don't.
would be better, I think.
Yes, sir. Options would be very nice.
So in the last time we cannot give these things. Okay, so everything is already set up. Okay, so yeah, I've already seen said many times. So just focus on the graph algorithms. Other than that, all the problems will be based on the logical part.
So I think graph and sorting are most
Searching,
important.
sorting,
Searching binary
yeah, or
search
link, or this
Also,
list.
basic data structure operations. So
and sir, we didn't mention like heaps and binary.
no, not
Sir, heaps would
heaps,
be
AVL tree, this type of closure pair path, this
to
type of
construct AVL
yeah.
tree or heap tree.
No, not required.
No, sir.
So uh, so one thing's linked list operation can you perform? If we said that, so in the previous, maybe I remember that in the previous OPP exam, previous term, so some questions were based on the linked list operation. So remove the middle element and insert the element at the middle position.
Okay.
So this type of question are actually logical based. So there is no need to remember any algorithm for this type of
These
question.
questions are covered in live coding, right?
Everything. Also, many questions I have already discussed in the live coding and practice assignment, which is already used in the OPP.
Okay.
Okay. So if you have done all these
KPA
things,
session was different, right? In that some other person was
PPA
taking, right? KPA discussion session was different, right? You
PPA
didn't take that.
discussion. No, that is
That
actually
was
Harshit is taking.
Harshad, yeah. Harshad, sir.
Okay. Okay. So I am starting the solution part.
Yes,
Okay,
sir,
so in
please.
last time, just focus on the exam. Okay, so this time I think nothing can be changed. Okay, so the first, yeah. So this is simply a logical based question. I think there is no algorithm is required in this. So here we are asking that you are given two lists A and B of n positive integer each. You can apply the following swap operation to them any number of times. Select index I. So index range is given 0 to n minus 1 and swap AI with BI. That means you can perform the operation. You can swap the elements from the each list which have the same index. Okay. So that operation you can perform. And what the asking is that write a function min max a comma b which takes two lists a comma b a and b of size n, that means size is same, as input and return an integer which is the minimum possible value of max of first list and max of second list. You can get after applying the swap operation any number of times,
Cross
possibly
product,
0.
right?
Cross, no, so this is
Cross
multiplication, simple.
multiplication, yeah.
So max of the A list and max of the B list. So that this multiplication should be minimum after performing the swapping operation. So can anyone explain the logic? Very logic is very simple for this. and the code you can write only maybe 4 or 5 lines. Yes, Neha.
Actually, in one of the element we have to consider the maximum number. Means suppose if we are taking a of I, then a of I should contain the maximum elements and b of I should be containing the minimum elements compared to after comparing.
Yes, yes. Okay, so we can simply compare the elements from the AI to BI, and we can shift it all smaller element in one list and all greater element into another list. Okay, simply compare AI to BI and check that
But
if AI
sir,
is smaller than BI, then keep so all the after swapping all the elements which are smaller when we are comparing should remain in the one list, and another greater element should come in the second list. Yeah, Manan?
but sir, my one doubt here is the elements in the A list, suppose, will they be strictly less than the elements in B list? I mean, as you said, the
If you
minimum.
if they are equal, so there's no need to there is no
Okay.
need to shifting.
Suppose if there are some common elements in both the list,
Mhm.
and so that won't be changed.
Yeah, so I'm just taking this example. If common elements are there, so there is no need to shifting because both are equal value. So you can there's no need to swapping the elements. Okay, so here this is the sample input is given. So you can see this is the A list. 1 2 6 5 1 2. Okay, this is the another list. Okay, so simply compare. This is the A list, this is the B list. Okay, and simply compare the elements by like this. AI is less than equal to. Okay, so you can take equal sign, or and otherwise you can take this equal sign in the else condition. So BI. Okay, so if this condition is true, so no need to perform any operation. If this condition is not true, then in the else part, so if this is true, so no need to perform any operation. In the else part, you if this condition is not true, then swap the elements. You can simply write AI comma BI, so equal to BI comma AI. Like, just swap the operation. So if you are taking this example 1 and 3, okay, so what is our main focus is, so all when we are comparing each index element, so in the comparison, if smaller element we are getting in the first list, so all the smaller element should be come in the A list, all the greater elements should come in the B list. Okay, so if
Sir,
we
in
come
this, sorry, sir, in this, is there any keyword called swap to swap the elements in both the list? I
no,
mean,
there's no keyword. You can simply perform the swapping.
Okay, by just the indices.
By just using this A, just go through one loop for
Mhm.
I in range. Okay, so range inside the range you can take the size of any one
Size
list,
of
because the size of both lists are same. So like you can like len of A in this. Okay, and just use one condition. If AI is, sorry, not AI is less than or equal to BI. Okay, so you can perform any operation for this condition. Otherwise you can simply like pass, or else part you can swap the elements. So A of I comma B of I equal to B of I comma A of I. Okay, so in that way you can perform the swap operation. So this is the main logic for this problem, and after performing this, simply find out the what is the max of A and multiply by max of B.
After swapping, we have to do this, right?
After completion of this for loop. Okay, after completion of this for loop, so outside of this for loop, return the result. Return this max of A into max of B.
Sir, is it possible like the list are unequal?
Unequal means
different length.
Length of.
No,
list.
length is in the problem statement it is given. that the size of the both list is n.
You won't be able to swap if it is unequal.
Yeah. So in this case,
Why do
if we
so sorry to interrupt. Why
huh,
do we need this pass one? What can't we do if bi is greater than a I
yeah,
and
so same things you can perform swap here. Okay, so you can perform swapping here, and no need to use this else part then. Okay, so
yeah?
our basic purpose should be happen here. So what we are doing, we want to shift all small element in the one list. So you can shift either in B or either in A. So if we are following this code, so all elements of 1 and 3, so 1 in the A, so we can write simply one A and B, and in the first comparison we will get 1 inside this A list and 3. In the next iteration 2 and 4, so same things, no need to swap 2 and 4. In the next index 6 and 3, here we need to swap. Okay, so we will swap the elements, and 3 will come in the first list and 6 will come in the second list. Same for the 5 and 2. 2 will come in the first list and 5 will come here. And next 1 and 2. So no need to swap. And 2 and 5, no need to swap. Okay. So after performing this swapping, simply find out the max element from this list. So this is 3. And max element from this list, this is 6. Okay, so 18. This is the answer. Okay, so you can write the code only using this one for loop, and after that directly return max into max p. Okay, so this is the basic logical based question. Now we move to the second problem. So I think this if you remember that we have discussed this problem in any one live coding.
I think GRP or some.
Yeah.
No, sir. In live coding, you have discussed.
Yeah, in live coding I have discussed. So consider an list A with n entries, with each entry holding a distinct number. Okay, distinct number. The sequence of value a0, a1 dot an minus 1 is unimodal. So what is this unimodal? For some index p between 0 and n minus 1, the values in the array entries increase up to the position p and a in a, and then decrease the remainder of the way until position n minus 1. So simply elements are increasing till one position, and after that elements are decreasing. Okay, so some pattern is there. You have like element in that way. So if we draw the graph for this, okay, so this graph can be like this. So elements are increasing. Okay, in our list elements are increasing, and after any points, any position or any index, or elements are decreasing. Okay, so that means value is increasing like 1 3 5 7. So okay, this is the peak point. After that all elements are decreasing like 6 4 2, in that way. Okay, so this things is given, so our elements order are given in that way. So you need to find what is the peak element. I think peak element is asking. Okay, write a function peak unimodal that takes a list A as input and returns the index of the peak in A in login time. So here login time is given. So you can think about the binary search approach here.
Yes, binary search.
Okay, and in binary search, do not use slicing. So just write the code without slicing for this. So now just identified that how we can. So in this case,
So
okay.
can we just use the max function?
No, you cannot use
It
max.
it take n order
Yeah,
n.
complexity will become n.
Yes.
Okay, so you can try the max things here and just check how many test cases are passing. Okay, so just think about the binary search approach and think about how you can identify the element. So suppose the elements are given in this way, in this order. So first are increasing and then decreasing. So the peak element identification is that all the neighbors elements of this peak element will be smaller than this peak element. Okay, so if you see the peak element, all the neighbors element, if you see that this 5 and this 6 both are smaller than this peak element. This is the identification of peak element. So you can simply apply the approach of binary search, just find out the mid position. I think someone have yeah, Harshit.
Actually, sir, I there is a question in week 2. I guess PPA 1 or PP 2. It asks for the sorting. I just use the sort function, and it passes all the private cases too. But the complexity is different. So can we use in the tomorrow exam? Yes, tomorrow after exam.
Sorting. So that means you want to perform sort first in this list.
And no, I'm not talking about this question. I'm
Mhm.
talking about some other question which asks for the just sorting and the
Okay.
complexity. It asking for different, but I just use the sort function, and it
Okay,
passes all the
okay,
private
okay.
cases.
So that it depends on the problem. So what the problem is given, what the complexity is required, and what is the suitable approach for that. If complexity is required, like n log n, okay.
Okay.
So n log n, then you can use the sorting algorithms, because the sorting algorithms
I'll
is
take n log n
complexity is
times,
n
sir.
log n times.
Yes, sir.
Okay, so you can use, but here we are asking the solution in log n time.
Yes.
Okay,
So on this binary search,
so in log n time, required complexity is log n time, then you cannot use sorting, because sorting complexity is n log n. You cannot using the linear approach, because linear approach will take order of
N.
n time. Okay, similarly for
Yes, sir.
you cannot use slicing inside this binary search approach. Slicing complexity is order
Also
of
take
n.
n time.
Okay,
Yes, sir.
so you can think about only this binary search approach. So every time you find out the middle position element, and just check this condition, if the both neighbor are smaller than the middle element or not. Okay, so for suppose in this if this type of list is given, okay, this type of list is given, just identify, so what is the size, for example size is n, so you can simply identify the mid position. Okay, so mid you can identify by the starting index, start plus end index. Okay, so you can follow this start and end index, and just identify the middle of index. And after identify the middle index, just check that both neighbor are smaller than this or not. If at any time you are getting this condition true, okay, you can simply check this condition by this way. So for suppose list name is L, so you can simply check if uh, L of mid, okay, so we are checking for mid, L of mid is greater than L of mid minus 1, okay, and also greater than for L of mid plus 1. Okay,
so
if
it would be
this,
less
yeah,
than
no,
the
no,
less.
no, I am writing the condition when we are finding out the peak element. So if
Okay.
this condition is true, directly return the answer L mid. Okay, return the answer. If this condition is true, then you can directly return answer L mid, because you are getting this condition true. So both neighbor are smaller than this mid position elements. So that means this is the peak element. But if what happen if our mid index element is not following this condition, so then you need to move any one side, one half side. Okay, so just look this sequence. So suppose if you are coming on this index to check, so you are getting this condition true. But what happen if you are coming on this index, like for the 4? Okay, so for 4 you can find out the order. What is the so you can identify the order by looking the neighbors elements. So what is the order? So is the right side element is smaller than, okay, this is the smaller element, and so sorry, this is the right, okay, and the left side element is greater. Okay, so you can follow this sequence. So if your middle element is greater than the right side element but smaller than the left side element, so that means your order is increasing this side. Okay, So your peak element will come on the left side. If this order is increasing this side, so definitely peak element will come on the left side. So no need to check this part and completely skip this part. And so after mid, okay, so you can skip after mid line, okay, and in the next iteration just check on the left part. Okay, so based on this condition, if you are getting this type of element 6 which is like 4 2, so that means order is increasing this side. Okay, so peak element you will find on the left side. So you can skip all the elements which are coming on the right side.
Sir, end will be mid minus 1, right?
End will be,
the end index will be mid minus 1.
So you need to just check with after getting the mid position. So for suppose this is mid, just check with what is the mid plus 1 and what is the mid minus 1, and using this index just check that what is the order of elements. If you are getting this condition true, directly return the answer. If you are getting this type of order, okay, so that means you can decide that the elements are increasing into the left side. Okay, so that means peak element will be available on the left part. So no need to check on the right part. You can directly skip the right part and just check the next mid element on the left part. Okay, similarly on the different condition, if you are getting this type of condition 1 comma 3 comma 5, okay, so suppose you are coming on this 3, okay, just compare the this middle element with neighbors. So if you are getting this condition, okay, here left side is smaller and right side is greater, that means now the elements are increasing. Yes, Srikant.
भाई आर्यन आएगा तभी ना, तो मैं बोला 9 बजे चलेंगे, बताया था 9 बजे चलना है, तुमको बता दिए तो चलो ना, 9 बजे में निकलेंगे.
Yeah, so the elements are increasing now left to right. So this time peak element will come to the right side. Okay, so you can skip the all left part. So these three conditions are required to identify the peak element in this case. So first one is this condition is to identify the peak element. Another these two conditions need to identify the part which you need to check again. Okay, so this is the basic approach you can write for this.
So basically here what we are doing is, if the mid is the middle of the list, I mean the peak element is in the middle of the list, then we are simply returning the L mid, or else we are checking where the
another two condition. Yeah,
another two means.
And based on that you can decide the where you need to move. What is the half part you need to discard, and the next half part you need to check again. Okay, so I hope you can write the code for this.
Yes, sir.
Yes.
Okay, so and we have already discussed this problem in the live coding problems, so you can see the solution for this. Okay, and I'll also release the solution for this mock exam after this session.
Okay.
Okay, maybe after this session, or maybe tomorrow. And the next problem is mock PP3. Yeah, this is the graph problem, and so the title of this problem is shortest circular route. Shortest circular route. Here one story is given. Okay, and traveler made a travel plan which start from city S. Due to time limitation, he decided to choose the shortest circular route that return to the starting city S without using any road twice in the route. So the route need not visit all city. Okay, so that means one graph is given. Okay, so what is the actual things is here? So suppose we have one start point here, and like some vertex are connected in that way. Okay, so connecting this line. Okay, so as I'm giving some name A, B, C, D, F. Okay, and some distance are also given. Plus 1, 4,
Sir,
2.
for graph problems where the such stories are given, how do we break down the problem to understand?
Yes, so first thing, read the problem statement and then figure out what we are asking.
Okay.
Okay,
This
yeah, so this first statement is given. So you can figure out that the traveler made a travel plan which start from city S. Okay, the starting point is given. Due to time limitation, he decided to choose the shortest circular route. Okay, circular route means uh, if he is starting from S, then he will come on the same node S after
It's a
visiting. Okay,
loop, right?
yeah, loop
Mm.
things. Okay, that return the starting city S without using any road twice. Okay, so that means he cannot use the same road to
Mhm.
return. Okay, in that route, the route need not visit all the cities. So that means our target is not to visit all the nodes in the graph. Okay, so I'm just giving some examples. So here one graph is given. Okay, so and the weights are given 10, 5, 3, uh, 20, 15, 18, and 6. Like, okay, so next 7. So weights are given, and you are at this position 6, and now you want to just find you want to visit in this one circular route. So circular route can be anything in the graph, but you cannot visit one edge twice. Okay, in the graph. So that means you can follow this route. This is one circular. Okay, and another circular is possible. You can follow in that way. Okay, so no need to traverse all the vertex. You can follow any circular route. If you are starting from S, then after visiting some nodes, you just return to the same vertex. But the weight of the path should be minimum of a circular route. Okay, so follow that path which have the shortest shortest circular path, which have the total weight minimum.
So here we can use the extra algorithm.
Yeah. So how we can use, so a Dijkstra algorithm is already given in the code, I think, so in the
Yeah.
solution part. Okay, so some logic is required here. Okay, so if some extra logic is required in to solve the problem, so in that case we generally gives the algorithm.
So like in OPP, will, like, for example, the Dijkstra be given if
yes,
the
sir.
Yeah,
if the question requires Dijkstra?
yeah, no, not directly required. If some extra logic is required to solve the problem.
So the prefix and suffix code will be there.
So
Okay.
actually, you have some time limitation of 2 hours. So we cannot ask to write the complete all the codes with the Dijkstra algorithm, then logic. If some extra logic is required to think, so in that case, we are giving this Dijkstra algorithm. So you can use this algorithm, but some extra logic is required.
Different from the algorithm, we have to think.
Yeah, so you can take the help of this algorithm, but you need to focus. You need to find out some logic
Logic.
in this. Okay, so can anyone tell me what logic you can use in this problem?
Sir, we will try walking backward. We will try like how many edges are coming towards the S,
Mm-hmm.
and then try going the other side.
We will make a parent dictionary and we will store the parent of each node in a circular path and see which, and also we will keep track of the distance of the parent node and we will check which is
So
circular.
in this graph, okay, so there are lots of cyclic path are possible.
Yes, sir.
Okay.
So can we just like choose each vertex? Like we first choose A, and then we remove the SA edge from the graph and find the Dijkstra from A to S,
Hmm.
and repeat this for each vertex,
Yeah, correct. This is the correct approach.
removing all the
Yeah.
paths that we take
Yes.
from S to that vertex.
Yeah,
Could you
correct.
could you please repeat me? Like I did
Yes.
not understand. Please explain some more.
What I'm saying is, like, for each vertex, like from A, B, C, D, E, F, G, what we will do is we will first find the Dijkstra from S to A, and then
Okay.
perform Dijkstra on the graph without the edge S to A. Like if we remove the edge S to A, then it won't use that path, right?
Okay. Okay. Okay.
And then find the shortest path from A to S. And for like and
Okay.
store
Okay.
all these values, and then whichever is the minimum, we will just return that.
Okay.
Yes, this is the correct approach. So what we will do actually, we will find out the adjacent of S. So what are the adjacent of S is A,
A, B,
B,
C.
C. Okay, so that means you can traverse from these adjacent nodes only, and you can return the same edge. Okay, so these you have only 3 outgoing or 3 incoming edges from the S. Okay, so you need these things which is mentioned. So what you will do, so first things, suppose you want to find out the shortest path. So first things, what is the distance from S to A? Okay, so S to A
1.
distance is 1. Okay, and just note down this, what is the distance of S to A? This is 1. Okay, and after finding out this distance, just remove this edge from the graph. Okay,
So why are we removing? Because we can't
yeah,
use
so
this
suppose I have
path
removed.
twice.
Yeah, I have removed. Now just look the graph and find out that what is the shortest path. So directly apply the Dijkstra algorithm on this A node to find out the shortest distance for S. Okay, apply the Dijkstra algorithm on A and find out the distance for S. So Dijkstra algorithm will return the shortest path shortest path.
Yes, sir.
Okay, so that means we will apply, so we have the distance S to A1, and then we will add the distance using Dijkstra from A to S.
Do this thing for B and C also, and
Yeah,
comparing like.
so yeah, this is the first step, and after performing this step, so again add this edge on the graph. Okay, so you can use this different copy of the graph. Okay, here we are passing any adjacency list or any adjacency matrix. So after removing this edge and perform this operation, and after completion of operation, just add this edge. Okay, now same operation we will perform with second adjacent B. That means S to B, and this distance is 2. And plus we will, after that, after finding out this distance, we will remove from this edge from the graph. Okay, so I'm just crossing that, and we will apply the Dijkstra algorithm from B, and we will find out the shortest path for S. Okay,
So,
so
sir,
that
from
means,
B, we again have to go to S in the shortest possible
yes,
time.
yes, yeah, we are finding out the shortest circular path now, so our final endpoint is also S.
Okay.
Okay,
Mm.
so we are starting from S, so we are adding the distance S to B, plus what is the shortest path from B to S after removing this edge from the graph. So definitely shortest path algorithm will provide the shortest path, maybe from C to S or A to S through this to another edge.
Mm-hmm.
Okay, so this is the second possibility. Similar for the third possibility, third adjacent nodes. Okay, so same S to C, which is given as a 4, and we will same things we will repeat with this. So D, we will apply the Dijkstra algorithm on C to S.
Okay.
Okay, so how many adjacent we have from the source? So we have 3 adjacent nodes. So we need to perform this task 3 times for each adjacent, and after getting all 3 distance, we will return min.
Mm-hmm. Okay.
Okay, so this is the main things for this problem. So you can use direct, so this is the main logic for this. Okay, so you can use Dijkstra algorithm directly and you can get the distance, but you need to perform this operation, just remove the edge and then find out the distance from A to S, then again add the edge. This graph. Okay.
Yes, sir.
So
Mhm.
you can try to write the code for this approach. So
Can you just
I'm just writing the solution. So what is the function name? Oh, this is image actually. Okay.
shortest?
Shortest circular route and W list and S.
Sir, you can copy it from the suffix code.
Suffix. Oh, yeah, suffix is given. Yeah.
Sir, even the function name should be, I mean, similar, right? I mean, and whenever we are writing the solution.
Yes. Okay, so this is the thing, and we will maintain one list. So path. Okay, so we are just initializing a one list to store the all possible path. Okay, so how many adjacent we have? So we will store all possible path, and after finding all the path, we will return the minimum value. Okay, so this is the one things and adjacent list. So for adjacent nodes, we are maintaining one list. So how many adjacent we have, and in this list we will find out the all adjacent. So for uh, so we will find out the vertex. So for node, okay, node in. So what is the source node? S. Okay, and this our adjacency list. So this is given as a adjacency list. Yeah, adjacency list.
So we can directly write it as WL of S, right? ADG is WL of S.
You can also write this, but
Mhm.
we
Because
also need to perform this remove and addition operation.
no, I'm just saying ADG is equal to WL bracket S.
S, square bracket.
Because W weighted, it's a
It is not a dictionary. I think it is a
And
So what
list.
is this?
directed graph.
It is
So
a
actually,
list.
this is a list, and each list contains the tuples.
Mhm.
Okay, where the destination index is given and distance is also given. So we can also do this, or we can also filter only node information without the distance. Okay. So one second. Yeah, you can simply write this WL and S. So then this thing is not required.
so
Okay.
WL have to be capital.
Yeah.
So can you explain what you did just?
So I'm just simply writing the function. This is the function name which we need to write. After the first line, we are just initializing the one path list. In this list, we will store all the possible path from S to S. Okay, and we will just maintain the distance. We will store the distance of for all possible path. And after finding all the possible path, simply we will return the minimum of all possible distance, because our target is here to find out the shortest circular path. Okay, so I'm just initializing with this, and this is the adjacency list. Here we are maintaining this, what are the adjacent of source node. Okay, so we have adjacency list in dictionary format, where for each key we are maintaining a list which are directly connected from that this key node. So here key is S, this means source, and so this assignment operation will return one list that contain the all adjacent vertex of S. Okay, and after that we will simply perform these things. So for each adjacent node, okay, for each adjacent nodes, so we have tuples. So we will traverse the list. So for each ADJ in ADJ. This is the, I am just traversing each adjacent of the source, and what we will do, we can simply copy. We have adjacency list. Okay, so we can make a copy for our adjacency list. So I am simply writing ADJ list. Okay, so ADJ list equal to, I'm creating a copy here for WL. Or you can use another approach. You can directly perform the same, directly perform the operation on WL. Just remove the S, and after performing the operation, add the H. So I'm writing this thing, copy dot deep copy. You can simply write WL dot copy and WL. This is the copy of the adjacency list WL, and after that we will perform the same things. So from this list ADJ list, so this is a copy of this adjacency list dictionary. Okay, so we will remove S dot remove what we want to remove. So we are reading the adjacent vertex here. Okay, and what is the node value? Node value is given in the 0. 0. We have tuple inside this, and we are reading one tuple.
We will remove the entire tuple. So why mention 0?
Okay, yeah.
So before deleting, won't we take like Dijkstra from? Okay,
No.
Okay.
After
got it. Sorry.
removing, we will perform.
Okay, sorry.
Yeah. So. Okay. So we also need to add the weights for this. Okay. So before removing this, we will make a copy for distance. So dis equal to, what is the distance given for this?
So it would be each ADG and 1.
Yes, but each ADG and 1.
Route from adjacent site to the source. It is not there in the list.
Sorry?
The route from adjacent site to the source vertex which we have. Is there no from that? Is there only single route given to the source to that adjacent site and not the vice versa?
Sorry, I'm not getting. Can you repeat once again?
Like for source, we have adjacent sites. But for adjacent site, we don't have that source on that list, like the vice versa.
No. So in adjacency list, if we are so for what is the source? Okay, so we have to look this structure.
So
yeah, you are correct. Yeah, actually you are correct. We have to remove from the both side.
Yes, from the both side we have to remove this.
Yeah, this is the one side, and the similar for we will write. Now this time we will pass this each.
Yes.
Okay, but here this time 0. This is a vertex, and we'll remove S. So we will remove the tuple.
So why 0?
So 0 contains the edge, na? Vertex.
Yeah, this is representing key, na?
Okay. It is in the form of tuple.
Tuple form. So we are just reading the node, and here we will write the distance value. So we are removing the H and 1. Okay. Here we are directly writing this each, or we can directly, no, we cannot write directly right here. So we are removing this edge information from S to adjacent and adjacent to S from both sides from the graph.
So why we can't write directly, sir?
What directly?
I didn't get it, sir. Like whatever we write for S.
So our dictionary key is a vertex.
Yes.
Okay. Our dictionary key is a vertex, source vertex, and value is a list of tuples, and each tuples contains the destination vertex.
So just like from the source, we are removing only that.
Yeah. So from
adjacent side.
source, we are giving the value. What is the value inside this list? Okay, so from this, yeah, so from this list, okay, so for source vertex we have S, and from we have the value this completely list, and we want to remove this tuple.
Yes,
Okay,
sir.
so because of that, first in the first remove statement we are passing each adjacent. So each, if you see this line, okay, so this
Oh,
each adj, actually
it is
it
already
is
a tuple.
already a tuple, so we are directly passing this. So it will find out inside the
But
list.
if we remove all the adjacent side, then how can we reach back to S?
By the another adjacent.
Okay, okay.
By the another adjacent, no. Okay, so this is the one first remove statement. Same things we will perform from the reverse side. Okay, from the adjacent to S, because the graph is undirected. So same things we will perform. Now this time we are passing this node value, which is already mentioned in the uh, zeroth index in the tuple. Okay,
Okay.
here we are passing this as a key, and we are removing the source vertex. Now this is also in the form, so source, but the distance will remain the same, so we are reading the distance here.
Okay.
Okay,
Got it.
so we are removing the complete edge information from our graph. After
Yeah,
that, we will simply call our diaster algorithm. So suppose D, uh, and what is the function name? This diaster.
Dexter.
Okay, so source we can simply pass. So so what is source here now?
Source here is each adjacent.
Not completely. Uh,
Or zero. Zero
Zero.
index.
Okay, so this is a source,
And the list is
and W
adjacency list.
list is so we will apply this on this ADJ list. This is the adjacency list, and we want to find out the distance for S. Okay, this is the S. Clear? What we are doing? Someone is asking something. Yeah,
Hello,
Manan.
sir.
Yeah, Manan.
Yeah, sir, I didn't get this line 28.
28th line.
Yeah.
So we are calling simply diaster algorithm here. So diaster algorithm is this one, and we need to pass one adjacency list, and this is the source. Okay, and we are calling this diaster algorithm on the one adjacent, which we have removed the edge from S to that adjacent. Okay, so for this W list, at the place of W list, we will pass the our adjacency list. So we are passing our adjacency list. Okay, which we have copied.
Okay.
Okay, and for source we will pass the vertex where from we want to find out the shortest distance to S.
So, sir, each adjacent is a
Each
tuple,
ADJ
right?
is a tuple, and we are reading the first value.
First, yeah, like destination is the source now. I mean,
This is the source here.
destination,
So
yeah.
what we are, so if you see this graph, okay, so this is the
Yeah.
source. Okay, this is the source. What we are doing, we are simply removing this edge. So we are removing from S to A side and A to S side, both side. Okay.
Okay.
We
Okay.
are removing this information from the graphs, and after removing this, we are performing Dijkstra algorithm on this
Next one A.
on A as a
Okay.
source. Okay, and from this source A, we are finding out the shortest path for S.
S.
Okay,
Okay.
so we are simply passing this information in our Dijkstra function, and so you can see Dijkstra. This is the function, and this is the our data structure
Mm.
for
And,
graph,
and
and
so to
this.
copy the W list, you have used this function, deep copy.
Yeah, because some limitation we have if we simply write the copy things. So if you change anything inside the list of the dictionary, so that maybe reflect on the same on the main dictionary.
So is there any other way to create this
Sir,
adjacency
we can
list?
also use the dot copy
Yeah, you can also
for
use the
the
dot
W.
copy. Hmm,
Dot copy. I see.
hmm, yeah. So okay, and so we are calling simply Dijkstra algorithm, and the Dijkstra algorithm will return the distance dictionary. And in distance dictionary, this is a dictionary actually, and you can simply pass the key for the distance. So we want to find out the distance for S. Okay, so we are directly passing this S here on the function. So inside D, you will get the shortest distance from adjacent to S.
Hmm.
Okay.
So D is just storing the distance.
Yeah,
The
D is
shortest.
storing the shortest
Shortest
path
distance.
distance. Yeah. Okay. And now what we will do? We will simply add the uh,
Added to the list
hmm,
path, I think.
and we
Path.
will yeah, we will find out the complete distance. So we will add the so like this final distance ds equal to, so what is the distance from S to adjacent? This is the this one.
Distance plus D.
Okay, plus D. Okay, and we will add this in our path dot
Append.
end this final.
Final.
So final dis. Okay, so this is the one things, and after, so this is the loop actually. Okay, so every time we are performing these things for each adjacent. Okay, so using this loop, we will perform this operation with the each adjacent, and finally after completion of this loop, we will return
Main of path.
min of path.
So sir, path is a list storing the minimum distance
Hmm.
from S to each adjacent.
Yes,
I
yes. So
mean,
if for this graph, actually we are so path is the list that contain all these three distance. So this is the first, this is the second, and this is the third. Okay,
okay. Hmm.
and so all these three distance it will contain, and after that we will return the minimum of all three.
Okay.
Okay. So this is the approach. Okay, let me check. So what is this wrong? Well, it's syntax.
Oh, S is outside.
No. Actually, what we are doing.
Yes, sir. In the line number 28, I didn't understand that
S is out.
yeah, S is outside. How?
Okay, so I'm not writing here now. So I can write these things here. Yes.
So
So why it is
Mm.
necessary? It is only giving the distance, I think. Okay, no, it is
Yes. So
giving.
Dijkstra algorithm is returning a distance dictionary.
Okay, yeah.
Okay.
It will
In
return.
distance, yeah, in distance dictionary, you need to give the key.
Yes, got it.
Okay. So because of that, we are writing this ds. So let me check in another. So d equal to syntax error Dijkstra adj list. What is it? Syntax error.
Sir,
Any bracket is missing? Remove.
I think each adjacent.
Okay, one second. So I think this bracket was missing. Hmm. Yeah, okay, complete. Okay, so one bracket was missing on the previous line actually.
But sir, it gave error in 28 line. Why so?
Yeah, actually this previous syntax was not correct, so
So it
it
should
is
have given
showing.
error on
Yeah, it is
27.
not completed actually, so it is taking incorrect next line.
Sir, I didn't understand the indexing of line number 27.
Okay, so I'm just copying this code. Okay, so just look this code. Line number, which line you're talking about?
The second line, the remove one. Second. Is this?
This second remove we are using, this one. Okay, so both are true. Okay, so what we are doing actually, each adjacent. What is this each adjacent? So we are reading the list. So what we are calling is actually WLS. Okay, in respect of the previous graph, S. Okay, this is the S we are passing. So in ADJ, what we are given actually, we are giving a list that contains the tuple A comma 1 in that way. Okay, so B comma 2 and C comma 4. Okay, so we will get ADJ like this list for this graph when we are writing this line. Okay, and after that we are reading each tuple from this list using the for loop. Okay, so this is the next line. We are reading each tuple from the list, and what we are doing, we are simply making a different copy, and after that we are reading the distance. So for first value, okay, so we are reading a1, so we are reading a comma 1 in the tuple. Okay, so what so this is from S actually, this is from S to A, and we are reading the distance. What is the distance between S to A? So this is 1. So first step we are performing these things. So this is the distance actually, each ADJ and first value. So
Sir,
this each
each
ADJ actually,
ADG is a
yeah,
tuple, right?
yeah, it is a tuple. Okay, and first index value is a distance. So that
Okay.
means each ADJ is returning this complete tuple, and we are reading this value. So this is the 0 index, this is the 1 index. Okay, so we are reading the distance. So in DIS we are getting 1. Okay, after that what we are doing, we are removing this edge information. So how we are removing? So you can see our graph is connected like this, S to A, and the edge is undirected. So that means the two side information will be available in our dictionary, S to A and A to S. Okay, so that means in our dictionary we have one key, and inside this list we have one a comma 1. Similarly, the for the same edge we have also a details in our dictionary like this, S comma 1. Okay, so for the same edge we have two information in our dictionary, S to A and A to S. So we need to remove both from our data structure. So what we are doing in the first line, we are simply removing this ADJS. Okay, that means we are removing from this edge when the key is S. Okay, so we are passing this key and S, and from the S, okay, from this S, so when we are passing this ADJ list, okay, ADJ list, and we are passing this key, that means we are performing operation on this list, and we are passing what element we will remove. So we will pass this complete tuple information. So inside this remove, you can see we are passing each ADJ. So each underscore ADJ is representing a tuple.
I think it is not necessary to use the first remove because it is the outgoing edge, not the incoming edge.
No, here the graph is undirected.
But
So
sir,
there is no
the
meaning of outgoing or
but sir,
incoming.
dictionary is specifying only the incoming edges, only the outgoing edges. So, sir, I tried it without the first remove and it is working because there is no outgoing, incoming edges. Only outgoing edges are
So is it passing?
yes. Yes, it is passing.
Okay.
Okay. Yeah. So actually, we are just checking the when we are performing the operation digest algorithm. So we are reading the key actually from key to value.
Yes, sir.
So in that way, so I think it will be work. It will be work. But
Yes,
for
sir.
the safe side,
Yes, sir.
okay,
Yes, sir.
just remove the both. Otherwise, it can also be create a problem in some case. In case, any case. So for safe side, remove the complete information of the edge. Okay, and for the second side, okay, so we have removed these things from this S list. Okay, this tuple we have removed. Now for the second side, so we have also removed this A to S. So for A to S, what we are doing, for the same graph, we are passing each ADJ 0. So each ADJ is a tuple. Okay, this one, and 0 we are passing this. Okay, A. So that means we are passing key now. This time A. Okay, and a value is this one. That means we want to delete from this list. And what we are removing, so we need to pass this complete information of tuple. What is this S value and comma distance value. So here we are just remove. We are inside the remove. We are writing S, and what is the distance? So distance is each underscore edge comma 1. So we are passing this tuple information which we want to remove. Okay, so both tuple will be removed from S side or A side. So now the complete edge information will remove our data structure. And after removing this, we are directly applying this digestion algorithm on our adjacent node. Okay, so in this graph, after removing this, we are performing digestion algorithm on this, and we are finding out the shortest distance for S. So
We are applying Dijkstra on each adjacent list, right?
yeah, so in
Adjacent
a
node.
node,
Node, yeah.
yeah. So every time we are reading one node, no. So we are applying one adjacent node we are reading, and we are applying this digestion algorithm on that node to find out the shortest path for 2S after removing H. Okay, so we are just passing this. We are passing this data structure adjacency list, and we are passing this node information, which node we are applying, considering as a source for digestion. And this digestion algorithm is returning a distance dictionary D, and final distance we will calculate the distance of the edge which we have removed. So what is the distance for this edge, and after plus, so 1 plus, and what is the shortest path for A to S by the digestion algorithm. Okay, so you will get the distance one distance from one adjacent. Same things we will perform with B. Okay, so 2 plus B to S using the extra. Similar for the C. So 4 plus C to S. And after getting all these three distance, we will return minimum. Okay, so we are performing after completion of this loop. Every time we are storing this distance in our final distance, this path list, and after completion of this loop, we are simply returning a minimum path, min of path. So it will return a shortest circular route information. Okay, so I hope it is clear.
Sir, in the OPP, like for such questions, will there be like a time complexity that we have to achieve?
No.
So can we just expect time complexity for a question that involves binary search or something like that? Or
Yeah, if anything is specific is given in the problem statement, like this is the required time complexity, so you need a efficient algorithm for that. But
Means it's possible.
we generally for this type of graph based problem we not give the time. Okay.
Okay, and can we expect such questions where like the algorithm is given, but we need to like use the algorithm itself for to solve the problem?
Yes, yes, you can expect this.
Means we don't have to remember
Yeah,
algorithm each time.
yeah, but sometime if the problem is directly based on the algorithm, so like minimum spanning
Mhm.
tree. Okay, so we are
Yes,
simply
yes.
finding out the shortest, minimum connection
Mhm.
network. Okay, so then if in that case you need to write the algorithm.
But that question generally we can't expect, right? No PB.
No, no, you can expect. Why not? In the
Okay.
previous OPP, I think some question was directly based on that.
Mm.
So because of that, I've mentioned that just remember one spanning tree
And
algorithm, one shortest path algorithm.
I mean,
So
you won't
basically,
give
when
the
there is
direct
an
approach.
use case of that algorithm, then we can expect the algorithm
Hmm.
is given to us. And
Yes.
if we have to directly calculate, let's say, the shortest path or the minimum
Hmm.
cost spanning tree, then we have to apply the algorithm by ourselves.
Algorithm. Yes. Yes. Yes.
Sorry, can you repeat?
Yeah. If some extra things is required and some like here, okay. So
Okay.
some extra logic is required. This part.
Uh-huh. Mhm.
So in that case, this algorithm is already given.
Okay.
Okay, so suppose if any problem is given where we are simply asking that what is the shortest distance from this source to this what destination.
Mhm.
Okay, in that case you need to write the algorithm.
Okay.
Okay, so direct where some extra logic is not required. Okay, so then problem is directly based on the
Yes.
algorithm. Then you need to write the code. Okay, so now the next. Yeah. So this is the problem. In Dominoes Solitaire, you have a grid with two rows and many columns. Each square in the grid contains an integer. You are given a supply of rectangular 2 by 1 tiles. Okay. Each of which exactly cover two adjacent square of the grid. You have to place tiles to cover all the square in the grid such that each tiles cover two square and no pair of tiles overlap. So score of the tile is the difference between the bigger and the smaller number that are covered by the tiles. The aim of the game is to maximize the sum of the score of all the tiles. Here is an example of, so here example is given. So I am just copying this example and explain what they are asking. So here this information is given, this type of data is given. Okay, so now you can apply that this tiling thing. So the tiling operation you can, so you can suppose apply this tile like this. Okay, so you can suppose this is the one way, one possible way. Okay, and each for each tiles what we are doing, actually we are simply finding out the difference from the bigger element to smaller element. So what is the score for this, if we are selecting tile in that way? So 8 minus 6 plus 3 minus 2 plus 9 minus 7 plus 2 minus 1. Okay, for each tile. So what is the score? Okay, same things we can select the tiles in the different way. So for you can see this example. Okay, so we are simply finding out this vertical tile, then two horizontal tiles. Okay, and last vertical tiles. Okay, so same things we can calculate the score by the same way. So we are getting 16. Okay, and when we are using this approach, so we are getting 6. So there are multiple way are possible to select these tiles. Okay, so we can select all the vertical tiles. It is also possible. Okay, so like we can select simply this in this way. This is a different way. So what is the total score? So in that way, what is the minimum score is possible? So this total should be minimum. Okay, so here there are multiple possibility to create this score, and we need to find out the minimum score. So how we can perform this? So at any time when we need to explore all the possibility to get the answer, okay, and the problem is related to the minimum or maximum things, okay, so at that time you can think about the DP approach. Okay, so you cannot arrange this order, or you cannot identify the any specific tiles order directly, so you need to explore all the possible order to find out this minimum score. So this is the one way, this is the another way, this is the another way. So in this case we can think about the DP problem, and we can systematically solve this problem by the smaller problem to a bigger problem size. So just think about that. Suppose if you have a tiles, uh, if there is no tiles, okay, so if suppose this first list is empty, so this the data input is given in the list forms, okay, so the first list elements are given in the one list 8 6 2 3, and second elements are given in the another list 9 7 1 2. Okay, so the data is input is given in this way. Okay, let me check once again what is the input. Yeah, so size is given 4 and the elements are given, and you need to, so
What is the
we
number of columns?
number of value in each.
Okay, each row.
Okay, so I think in this problem you no need to write the function, directly read the input. Okay, so in this way you can directly read the input, you can read the n in size, and then you can read the elements. Okay, so you can create a list after reading the elements. So suppose you are creating this list and n is equal to 4 here. So suppose both lists are empty, what will be the score for that?
Zero.
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 Okay, so if we have empty list, so that means answer is 0. Okay, so now suppose we have only one element in each list. So this is the this is the solution for example, if I am just storing the answer in D, any D list. Okay, so D, if we have size 0, the answer is 0. Okay, suppose if we have the size 1, each list contain only one element, so like 3, this is 2, then what is the answer? You can directly calculate.
Return the actual, like the difference.
So
Absolute
yeah,
of
so
this.
only one possibility is there, you can create only vertical tile. Okay, you cannot create any horizontal tile because we have only one element in both lists, so that means we have only this type of input. So in this case you can only create a vertical tiles, and for this vertical single tiles you can directly return the answer by what is the max of both. Suppose this is the A and this is the B, so what is the max of A, and what is the element index, for example I, and BI minus uh, minimum of min of AI comma BI. Okay, and you can directly put this answer at a if size is 1. Correct, we are finding out the maximum element from both, and what is we are finding out the minimum element, and we are creating a difference. But what happened where if we increase the size? Okay, so suppose now we have two elements in both lists, so like 2 3 and 1 4. Okay, now the possibilities increase, so you can select either in this way, vertical way, okay, and you can select horizontal way. So now you have to
Can't,
think of,
hello. We can't take a
yes,
cross trial, right?
no, not cross. Okay, so now
Okay, sir.
in that way we can think about, we have the solution for smaller problem, we have the solution for D0. If we have empty list, we have this solution directly 0. If we have the one size list, so we can directly return this solution. Now we will use this sub solution to generate a bigger solution. So how we will find this solution? So okay, I'm writing a 4 size. So 8 comma 6 comma 2 comma 3, and similar for 9 comma 7 comma 1 comma 2. Okay, so both are the different lists like A and B. Okay, now we will create a solution list of the size. So what is the size is here? N equal to 4. We will create one list that contains a 5 element, n plus 1. Okay, so this is the first. So this is the 0 index, 1 2 3 and 4. Okay, now we are simply assigning the, so we can simply solve this problem. We can start from the backend side. Okay, so we have only 4 index, 0 1 2 3. We don't have the fourth index, so we can consider the solution for 0 if we have no index element. Okay, so there is no element at the fourth index, so we are just finding out the 0 value for this. Okay, so the D4 is 0. Now for D3, so suppose if we increase the size from the right side. Okay, now if we are considering that this 4 is the empty place, we are finding the 0 solution for this. And now I am increasing the size. Okay, so I am just considering this third index in our problem. So in this case, we can directly return the solution using this approach, D1. Okay, so we can simply put the value using by the calculation of this. So D1, suppose this is a any value, so I'm just writing it D. Okay, after that what we are doing, I'm including this 2 and 1. Okay, so I'm simply just consider that 2 1 we have 3 2, and this is the empty place. Okay, so this is the empty place, we are just finding it, this is empty. Okay, now we have this type of list. Okay. And we have calculated the solution for this part. We have already calculated the solution when we have only 2 row. Now we are finding out the solution when we include this row. So what is the possibility here to create? So we can create a vertical tile, okay, for this, and we have already solution. We have already a solution for this previous D1. So first we will find out the, if we are calculating a vertical tile. So I am just denoting by the vertical. So vertical is possible for this index. Vertical is possible for what is the maximum of all these two elements. So max of this position A, B, and minus min of A, B. Okay, so this formula we are applying on this tiles. Okay, and we have already solved this part, so we will simply add the solution of this value. So D3 we can write. This is the one possibility. Okay, so I am directly reading the calculated solution which we have already calculated for this in the previous steps. Okay, so if I'm taking vertical steps, so I am just calculating the solution for this vertical tile, and we are directly adding the solution of next this part which we have already calculated. So this is the one vertical when we are considering the vertical tiles. And similarly we can create a horizontal tiles. So in the horizontal tiles we can create a tile in that way. Okay, so we have only two options. So in that case we will simply calculate the max of A. So this is the, for example, this is the second index, so A2 comma A3. Okay, and minus minimum of A2 comma A3. Okay, and this is the one. And what is the second tile? I am just adding plus. Second tile is the lower one. Okay, so same things, max of B2 comma B3 minus minimum of B2 and B3. Okay, and plus we will also add the solution of the next part. Okay, so we will repeat this process. So we will add the solution for D4. Okay, so these are the two possibility, and we will return what is the minimum value for both. So what is the value for when we are taking the tiles in that way? So what is the value for this, and what is the value when we are taking the horizontal tiles? So, and we will return min, and what we are getting min we will put here. Okay, so d, so this is for example d4, and here we will not d4, 3, and we will get d2. Okay, so this is the way, a similar way when we are adding the next. Now we have calculated the solution for this value till this value and till this value. What is the solution? Okay, and similarly we will include one more. So we will include this next row. So 6, 7. Okay, and 2, 1, 3, 2, and this is the empty. Okay, so we have already calculated the solution when we have empty. So this is d4 solution, and we have already calculated d3, and we have already calculated d2. Okay, so same process we will repeat with the these things. So we can create either these things, we can just select this vertical tile, and we have already the solution of the previous part. Okay, so we will simply add d2. Okay, and other things. So this is the one option when we are selecting vertical tiles. So vertical side we will select this here and plus d2. And if we are selecting the tiles in that way, so we are calculating horizontal tiles, okay, and plus d3. So we have already the solution till d3. So we will read this d3 solution. Okay, so this process we will repeat till d0, and at d0 we will get the answer.
Means are at the leftmost part of
So
the...
so every time we are finding out the minimum, actually we are using this minimum value now. Every time when we are calculating, we are finding this minimum. What when we are choosing vertical tiles, what we are getting, when we are choosing horizontal tiles, what we are getting, and we are selecting minimum. Okay, so at every, when we are calculating second, that means we are getting the minimum possible answer till here. Okay, when we are getting the solution for this one index, that means we are getting the minimum solution till here. And when we are getting the this zero index, okay, so that means we are getting the solution till all the elements.
So if we are taking the horizontal one, then we will take the solution for the next one.
Yeah, next one.
It's skipping one.
Yes,
next
yes, after skipping, because we are including the element, no?
Yes,
We are
yes.
including the next elements.
Yes, that is
okay,
why,
but
okay.
when we are taking vertical tiles, we are not including. Okay, we
Yeah.
have already solved previous solution, but when we are taking this horizontal, we are including this element, so we will adding the next element, next
So
solution.
at a time we can take 2 tiles, right? I mean, we can
In
cover 2 squares.
horizontal, yeah, horizontal. In horizontal you can only cover
2
these
squares.
Okay, and add the solution of next one. Okay, so after what is the next index, just directly read the solution from this solution list which you are maintaining. Okay, so no need to check the remaining part.
We have used DP approach, right?
DP approach we are using. Actually, we are starting from the sub problem when we have empty list. So we are directly writing 0. We are including the next solution when we have only one element in each list. So we are simply creating a vertical tiles, and we are directly returning a solution using this one formula. Okay, max or this min. And after that, when we are calculating the shortest solution for this, we are including this second index. So we are reading the solution from the which we sub problem which we have already calculated, because that is
we
the
can all do this thing from any of the ends, from starting or from...
Yeah, you can also do from the starting.
Yes.
From the left also we can start, right?
Yeah, from left you can also start. You can same things. You can also start from the last. So in that way you can write the code. So I'm just writing the code. We get the idea. So this is, yeah. So here actually we are not writing any function. So, or we can directly read the input and we can print the output here.
Printing.
Okay. So you can directly print the output. So simply what we will do, we am just simply writing n equal to int input. And we are getting two list. Okay, so we can create a two lists here.
Hmm.
So you have to you have to split all the elements. So suppose I'm just writing a L1 equal to, and you can using a for loop or not for loop. So you can using this int of I. Int of I, okay. So int of I for I input.
Okay,
I'm
for
taking
I
input, and inside the input, I'm just using the dot split function. Dot split by space. So we will just okay, by default it will take
So
space.
to create a space.
So what we are doing, we are simply taking the input and we are splitting that input, and we are reading each element after splitting. So that is actually a string. Okay. So that is each element is a string. So we are converting this into a integer form, and we are creating this list. Yes, someone is asking. Yeah, Harshit.
So can we expect us at least one question from the dynamic, like the mock?
Yes, you can expect one from dynamic or maybe from greedy.
Okay. And so in the earlier of this meeting, you mentioned that heap and the AVL tree vagera, this not come. Like week 6,
Yeah,
you
no,
can
no. So
skip.
this, yes, you can skip
Okay, sir.
means we are not asking
Not
any
prioritize this. Like not prioritize
algorithm.
this
Yeah.
first.
Mhm.
Okay, sir. Okay, sir. Thank you,
Okay.
sir.
Also, can we expect this kind of difficulty? Because, like, honestly, I would not have been able to think of the solution.
True, sir.
No, no. So
But I think
difficulty
this is
level will
the
be.
difficult question of the all 4 questions.
Yeah.
This is last question.
And the all question will be contain the same marks, 25%.
5 marks, right? 5 each.
Not 5.
So I think everyone is
25.
having this difficulty in dynamic programming.
25 marks
So
for each
you can
question.
expect the level which you have already solved in the Beak 9 and live coding problems in the same level, not this type of level.
So honestly, that too is like
Yeah, actually, we have taken this question from the starting terms. At that time, we are just normally giving the difficult question.
Mm.
Okay,
Week 11.
so just try to solve the DP problems from week 9. Okay, so which we have given in the live coding and practice and grading. So you can expect the simple problem, not the two-dimensional problem we are not giving. You can expect only one-dimensional solution in the
So this is
DP.
next level, right? In DP. Next level of problem in DP.
Yes. So this is actually a one competition problem which is used in Indian National Olympiad in Informatics 2008.
Mm.
Okay, so uh,
Level is high of
the
this
level
question.
is high. Yeah, this is the competition problem actually. And same things you can read the second list. Same line is here. Now after that, after reading this element, you can simply write the code for this. So and what is the, and we have already read, and okay, so okay, so one case we can directly write here: if n equal to 0, return 0 solution. Not return, just print. Okay, in this case you have to print actually, print 0. Otherwise you need to write the, so you need to create one list. So for example, answer, and we are creating like 0 for I in range n plus 1. Okay, so this list we are creating to contain the solution.
This is a list of zero value, right? Zero
Yeah,
indices.
yeah. So we have n element. So we are creating one more size, and initially we are assigning the zero value for each index. Okay, and the first case. So we will start the what is the value for n minus 1 index. So last index is actually n. We are taking this n plus 1. So index is starting from 0 to n. So we are filling this n minus 1. So what is the case of n minus 1? When we have one element. So in that case, we can create only vertical tile. So we are just directly writing the solution max of and L1 uh, L1 of n minus 1. Okay. So what is the L minus 1 position? Comma L2 n minus 1. And max of this. Okay.
So you can just write absolute value of the difference. Like that would be like
That is also
writing by
ABS, yeah.
L1 of -1 minus L2 of -1.
L1 not minus 1.
That's one.
Yeah, or n minus 1 we can relieve. This is the last index actually. Okay, and comma, not
no,
comma,
L2 minus 1.
Yeah, L2 n minus 1. So this is the value for second last element. Okay, so this zero value will remain same for at the n index and n minus 1 index. We are filling this value, and after that we will perform this loop for I in range. We will start from n minus 2, and till minus
-1.
1.
Minus
So we need minus 1, and every time we are reducing minus 1. Yeah. So now we will fill this answer list. So we will use the same things. So first we will find out the vertical solution. So what v equal to, and in the vertical case, so we will select the same things. Absolute, we will use this directly. And what is the value of I? Okay, current index and plus, and what is the solution for next? I plus 1. Okay, so this is the solution for vertical when we are taking vertical tiles, and another is H. So here you need to find out the solution for L1 and L1. Okay, so this is also L1 and this is I plus 1. Okay. Plus same things for L2. Now I am taking horizontal tiles plus answer of I plus 2. Clear? So this is the case when we are selecting vertical tile and we are adding the next solution, next index solution. Okay.
So answer of 2.
Answer no, so I plus 2. Sorry.
I plus 2. Yeah.
And this is the second case when we are selecting horizontal tiles. So we have two tiles actually for the first list, and this is for the second list, and we are adding the solution of I plus 2 because I plus 1 we are adding inside the tile. So we will add the solution of I plus 2, and after that we will find out the solution. So this inside the for loop. Okay, so we will save the answer at the place of I equal to min of
V comma H.
V comma H. Okay, so in that case this answers list will filled, and we will return the print the solution, print
Answer of 0.
ans of 0.
0.
What is this now? If
Is
okay,
equal.
one condition is this one. Still not correct.
Wrong answer.
So you didn't specify it. If n is equal to 1 only, then we have to use.
No, if n equal to 1, we are filling this now. So we are calculating these things here.
Yeah. Okay.
So what is this? This mistake. So minimum, actually, what is our purpose here? Minimum or maximum? Maximize the size.
Maximize.
Oh. Okay, sorry, max. Anywhere we are using this thing? No. Yeah, now this is. So same things can be asked for the minimize. Okay, so just use the min. Okay, so this is the approach for this. So you can see the solution is not big, but logic is here.
Logic is very tricky. Even
Okay,
if
so
you think for 1 hour, then also I don't think we will reach near to this.
But you can expect 2 problem with easy problem in the OPP. Okay.
Okay, sir.
So, like, will libraries, external libraries, be allowed in the OPP?
So we are not restricting any library actually. Those library you can use in the simple GRPA and PPA or live coding. You can use in the OPP exam.
So, like NumPy and
you can use.
Okay.
Yeah, we are not restricting any library. Okay, so I hope this logic is clear for this problem.
Yes.
So can you please show the full solution?
Okay. Yeah, this one.
Okay, sir.
Yeah, so for DP problem, just practice on the Beak 9 problems. Okay, so you can expect the same level of problems. Or yes. But just go through the graph algorithms. Okay, and remaining problem.
Graph and binary search and
binary search is basically approach, and you need to figure out that how you can modify the binary search approach.
Hello, sir. I have one doubt. Can I share my screen?
Okay, 1 second. Yeah.
so discussion over, sir.
Yeah, someone is asking.
Okay.
Hello, sir. Here, this logic is not getting here. If it is a k is lesser than lower, then I'm searching lower L to lower. So if it is a I need to find out the kth largest. So kth largest must be,
So this is the fast select algorithm.
yes.
Okay,
Yeah.
so you are showing this code from the GitHub, no?
Yes.
Okay.
So largest must be present by lower to high, upper, right? In that range.
Yeah, I'm coming on that. So someone is asking that week 10, 11, 12. So no OPP, that weeks are not coming in the OPP exam. Okay, and there is no content in the week 12 actually. So syllabus for OPP is till week 9. Yeah. So this algorithm is basically to find out the kth largest element.
Largest, yes.
So what you are not getting here?
This logic. So if it is a k lesser than equals to ln lower of ln, then I'll be taking L to lower. So L would be my 0. Lower would be my that you could say pivot minus 1. So but if it is a k means largest, so k must be present, you can say upper side. So we have a three, you can say two sides. One is a lower, lesser than pp, one is a greater than pp. So kth largest must be present greater than pp sides. So if it is a lesser, then I think if we take upper side, then we will reach to the you can say
Okay.
upper.
So you can stop this. You can stop here, and the same algorithm I am opening. Okay.
Okay, sir.
So this algorithm is belongs to
We
week
get 8.
Okay. Okay, the largest. This is quick select, and this is fast select. Yeah, so this code is given actually, and we are finding out the kth smallest, not largest.
Okay, but same code pasted into the GRP1 by I can say or PA.
So smallest means what is the difference between smallest? So for example, we
Smallest
have
would be,
the
yes, if
so
it is the smallest, then it would be what?
right. And we are finding out the second smallest. So second smallest is 2.
Okay. Then if it is smaller, then it will be work. But same code I think used into the PA, so that's why I confused.
So just check that the this part how we are going through the.
Yes, I saw. Then my logic, according to my logic, it would be working smallest. But in GRP1, I think not GRP, PP1, the same code you used, and that's why I confused.
Okay, let me check.
So in the PP1, say that kth largest. Find out the kth largest.
Kth largest, that accept the list here. Kth largest integer. And same code is working in this.
Yes, means I guess our PP not one session is conducted by you can say PP1. So that sessions the same code used, and I saw answer also got. So that's then I got confused.
Yeah, let me. I just putting this code.
Okay, put that code and check. I think am I wrongly.
So the function name should be kth largest. Oh, 1 second. Right. What we need to pass L, and the first value is okay. So first index, R value is the last index, and K.
L minus 1. Ln minus 1.
So this is the list, AR list. Okay. So just return. And what is the first index? 0. And n of RR minus 1. Okay.
Yes.
No. So just check the solution code. Maybe some logic part is different.
Okay, sir.
Okay. And yeah, so this is returning the different Okay, so you can see the solution for this. Here we are asking the second smallest, sorry, largest. Okay, second largest solution is 12. So this is the expected solution, but what we are returning, second smallest. This code is returning second smallest. Okay, so just check the solution. Maybe some little bit difference in the this last logic part when we are this
Can I
recalling
share
the
my
same.
screen? I can.
Yeah.
Or what could have been done is possibly instead of finding the kth
n
uh,
minus k.
largest,
You
yeah,
can
exactly, n minus kth smallest you can find.
Yeah, you can do in the same way.
Yes.
So,
Yes.
this is the code. This is the same code, I think.
So okay, so last row minus one. Just check the part where we are passing. We are recalling the same algorithm.
Okay.
Just compare that part.
So this is the last part is the main thing, right? Last part is the same. See, this last part is same. This part he also got answer. I don't know. Last part is
Like,
same.
No, what
once
you can do is like if you could go forward and see what he has implemented in the kth largest function.
Cat larger. Yes, this is the last. You can say this thing is a cat largest, right?
No, no, like if you could go forward, yeah,
yeah, can you open the initial part?
yeah,
What
yeah. So
initial part of the code? Just scroll up. No, no, not this. So this is the complete one. The screen is very small actually. One second.
Sorry, sir. Sorry, sir.
Okay.
Sorry, sir.
So you are showing the video. Okay, so video screen actually.
That's video.
Oh,
That video.
yeah. So some difference will be there. I think you are not able to identify it.
Yes, I saw multiple time, but I didn't get.
Some logic may be different. So lower equal to lower minus one, then what we are passing here. One second here. Lower equal to k is less than equal to lower. So one second. Okay. And first select. Actually, we have to check line by line this. Where is the
Yeah.
difference?
Actually, he had copied this code and the copy and pasted.
Mhm.
Copy from there and paste here and paste there.
So
Here,
it is returning a maximum value, no? So
yes.
some part may definitely will be different compared to the GitHub notes.
No, he copied from GitHub note. I can open. He told.
But I have already seen you now. I have already
Okay, sir.
put this code. It is returning a smallest value.
Yes.
Okay, so definitely some difference will be there. Just check line by line where the
Okay, sir.
logic is difference.
Okay, sir.
Okay, so any other things want to
No,
discuss?
sir.
Sir, you said that each question will be of 25%, right?
Equal
25 marks.
equal weightage, yeah.
Okay. Actual marks will be 20, but out of 100
No,
it
no.
will be
So the exam will be conducted for the 100 exam. Then later it will be converted for the
to
20.
20.
Hmm.
And sir, if we pass the private test cases, then only we will get,
Yes,
marks, right? Public cases won't work even if we pass that.
No, no. So the marks will be given only for private test case.
Okay. Thank you, sir.
Okay. Yeah.
So just any final like
Guru
golden.
mantra.
Yeah.
Okay, 1 second. Mhm.
So there won't be another mock, right? Or
No, no, no. So in the next week we will conduct maybe two session for week 11.
next week? I mean,
Hmm.
before the exam.
Before the exam, no,
I mean,
no,
16.
16 before the 16. So next
Okay.
week.